Let's do statistics. Woo-hoo. Okay. Measures of center. So, a lot of this stuff should be pretty familiar to you that we're going to do today. You'll just get a little more sophisticated notation today. So when we're asking for the center of these distribution of numbers, numerical values, we're either going to measure the mean or the median. So the mean, what's the mean? How do you figure the mean? Add all the numbers up and divide it by how many numbers there are. Okay. In math, what kind of symbol do you use when you add up a bunch of numbers? That summation thing. So my mean, which is usually abbreviated as X with a line over the top, heretofore known as X bar, is the sum, and I'm going to I'm going to start my index starting at 1, the first value on my data set, to the small nth value of my data set. N tells me how many numbers are in my set of my values, and we'll just call these X sub I. So now I've summed them. And now I divide by how many numbers are in that data set. Divide by N. Now in statistics, we will be a little less formal about this summation symbol. And what you will see written more often for the mean is no I equals up to N. You'll just see X sub I with the summation symbol divided by N. Don't know why, but in statistics they tend to leave off these indices. And when you're looking at that, some finite distributions, you really don't want to leave that off. Maybe infinite, I'd be a little more willing to leave off the indices, but we get informal. All right, so maybe let's grab out your calculator and find the mean of 3, 7, 8, 2, 0, 0, 12. What is that sum? $32? How many numbers have I written down? 7? So what is my mean? 4.57. Pretty good. What is the one more decimal for me? 1. Okay, good. All right. You may call the mean 4.57. You may call the mean 4.57, whatever the next number is. You may call this mean 4.6. You may not call this mean 5. So when you're averaging these values, and your values are integer values, you don't round this to an integer. Okay? So your means, you're going to want to probably go one more decimal than what the actual values are written to. Is that clear? Okay. All right, mean, that's easy. Let's add one more number to this set. We're going to add 457. So that sum is 489 divided by 7. 8, thank you. Oops. Which is 61.125. So I'm going to call it 61.13. Okay, so is this 61.13 a typical number for this data set now that I've added the 457? When I calculated that 4.59, that was a fairly central number to my data. But when I calculated this 61.13, it was a number kind of in the middle of all the data, but certainly not smack dab in the middle. And it certainly isn't a particularly representative number of my set. The reason it isn't is because 457 is an outlier. Okay? When we have outliers, means are not a very good measure of center. I'm going to say it's a bad measure of center when we have outliers. Okay? So this bad measure of center is described as that the mean is not, or non, I'll just say not, resistant to outliers. The mean changes. So the mean changes too easily. Okay. So sometimes we will use a mean. Sometimes we will use instead the median, the center value. And the median is often abbreviated X with a squiggle over the top, or just like in your calculator, just abbreviated MED. And the median is the center value when values are ordered. So let me go back to my my previous data set. 0, 0, 2, 3. I'm going to order those values. 0, 0, 2, 3. 7, 8, 12. Whoops. Get that definition back there for you. There we go. 7, 8, 12. And my median is a value that's going to be right in the middle. And what is my median in this case? 3 is my median. There's 3 values above it. There's 3 values below it. Okay. While I've got my numbers in numerical order,